get started with in-text question first. So this is your chapter number 9, Force and Laws of Motion. Force and Laws of Motion. In-text questions. In-text questions. In-text questions. This is page number 118, question number 1. So what is the question here? Which of the following has more inertia? A. Rubber ball and a stone of same size. Yes, please. Why? Mass of the body. Very good. So please write down. Please write down. Stone has more inertia. Stone has more inertia. So the first part is having the answer as stone. Stone has more inertia. Stone has more inertia because the mass of stone is greater than the mass of rubber ball. The mass of stone is greater than the mass of rubber ball. So stone will have the greater inertia. Okay, na? Than the rubber ball. Full stop. Next one. Next is a bicycle and a train. Obviously, a train. Please write down. The train has more inertia. Second one. The train has more inertia because the mass of train is greater than the mass of bicycle. Mass of train is greater than the mass of bicycle. Okay, got it? Third one, third part. A 5 rupee coin and a 1 rupee coin. 5 rupee coin. Please write down. A 5 rupee coin has more inertia. A 5 rupee coin has more inertia because the mass of 5 rupee coin is more than the mass of 1 rupee coin. The mass of 5 rupee coin is more than the mass of 1 rupee coin. So the third one is a 5 rupee coin. 5 rupee coin. Okay, so this will be the answer. I hope it is clear. First question is clear. Let's move on to the next one. In the following examples, try to identify the number of times the velocity of ball changes. That means the velocity is changing in this particular question. We have to determine कि कितना velocity change हो रहा है, कितने number of times उसमें velocity change आ रहा है. ठीक है? Let's focus on the question. A football player kicks a football to another player of his team who kicks the football towards the goal. Firstly, player 1 ने player 2 के पास ball pass किया football और player 2 ने goal की तरफ ball को pass कर दिया. Okay, the goalkeeper of the opposite team collects the football and kicks it towards the player of his own team. जो goalkeeper है उसने अपने टीम के किसी person को किसी player को अपना pass दे दिया. Okay, so also identify the agent supplying the force in this particular question. Okay, yes please. Yes, the velocity has been increased. Just wait. Please sit down. Anybody else? Yes, please. Okay, the velocity has been changed 4 times. Okay, yes. 4 times. How 4 times? Fourth constant. Which one is fourth? Okay, yes, you. First first velocity. Yes. Next one. Second velocity. Very good. Yes. Once please continue, beta. Once please continue. Just wait for a second. Yes. Please continue. Now you can turn on the mic. Please continue.
Ma'am, I want to answer. So can I answer?
Sorry?
I want to answer
Yes,
the
please.
question.
Please continue. What is the answer?
Ma'am, 5.
5. Okay. How 5?
Ma'am, before the ball is passed from first to second, it is 0. So first the velocity is 0. Then from first person to second player, that is 1. Sorry, with 2 times. Then the player kicks the ball towards the goal 3rd time. The ball stops. Goalkeeper stops the ball 4 times, and then the goalkeeper passes 5th time.
Okay. Okay. Good. Good. Thank you. Sorry. Let's start writing down the answer, please. Please write down. Yes, please. Please write down the answer. First point. First point. Please write down the first point. Velocity of the football. Velocity of the football changes. Velocity of the football changes when the first player kicks the ball towards the another player of his team. Please write down the second point. So this is from player 1 to 2. Okay, player 1 to 2. Okay, please write down the second line. Velocity of the football also changes when another player velocity of the football also changes when another player kicks the ball towards the goal. Okay, so see here first from player 1 to player 2 and then from player 2 to goal. Okay, third point. The velocity of football also changes. The velocity of football also changes when the goalkeeper, the third one is goalkeeper. When the goalkeeper of the opposite team stops the football. So this is the third one and fourth one. Please write down fourth point. Velocity of football changes. Velocity of football changes when the goalkeeper kicks it towards the player of a team. Kicks it towards the player of the team. Kicks it towards the player of the team. Next line में लिखेंगे. Please write down in the next line. Thus, 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 comma, the velocity of the ball changes 4 times. The velocity of the ball changes 4 times. Next line में please write down this way. Please write down in the next line. In case 1 and 2, 2, comma, the force is applied by foot of the players. The force is applied by the foot of the players. Full stop. In the third case, comma, the force is applied by, in the third case, the force is applied by the hands of the goalkeeper. The force is applied by the hands of the goalkeeper. Full stop. In the fourth case, the force is applied by the foot of the goalkeeper. The force is applied by the foot of the goalkeeper. So every time we have to mention that whenever the velocity changes, what is the reason of that velocity change, from where this force is actually coming. I guess the situation is clear till here. Is it okay? Let's move on to the next question. Yes, please. Next question is, explain why some of the leaves may get detached from a tree if we vigorously shake its branches. Yes, please. Some of the leaves may get detached from a tree because of the notion of rest. Very good. Because the leaves were at rest, due to which they did not want to add sudden shaking of the tree, and they tried to clear this. So, down, got detached and fell down, and then that is because of inertia of rest only. Yes, please. What's your answer? Same answer? Okay, please continue. When a branch of a tree is shaken, when a branch of a tree is shaken, comma, it comes in motion. Full stop. The leaves remain at rest. Comma, thus detached from the branch, due to inertia of rest. Got it? Next question, please. Next question is, why do you fall in the forward direction when a moving bus brakes to stop or fall backwards when it accelerates from rest? Please write down. Okay. Yes, please your answer. We fall in the forward direction when the bus backwards when it accelerates from rest, because the starting and when we are bus, we are in the notion of moving, and we tend to remain moving, but suddenly we fall backwards. And when it actually, we are at rest, and of rest, we tend to remain at rest, but when the bus suddenly accelerates, then we tend to fall back. Okay. Yes. Your answer. Inertia of rest. Yes. Remain in motion because of inertia. Very good. Please sit down. Please write down. Much one. Please write down. Give it as point number 1. Please write down. When a moving bus brakes to a stop motion, the lower portion of our body, the lower portion of our body also comes to rest, but the upper portion of our body remains in motion due to inertia of motion. Full stop. Thus, THEOS, thus, comma, we fall in forward direction. Thus, we fall in forward direction. Is it okay? Second point. Please write down the second point. First one was because of inertia of motion, and the second point is because of inertia of rest. Okay? Inertia of rest. Please write down. When a bus accelerates from rest, accelerates, from rest, comma, the lower portion of our body also comes in motion with the bus. But the upper part of our body remains at rest due to inertia of rest. Full stop. Thus we fall backward. Full stop. I hope it is clear to everyone. Is it okay? Next one. Next question. Next is on next page number, that is page number 126. I guess you have already completed 126. Let's move on to the next one. Chapter and exercises, page number 128. Page number 128. Page number 128. So half of the questions you have already done. Okay. So let's start with question number first. The first question is not done. Let's focus on the statement of first question, please. An object experiences a net zero external unbalanced force. Is it possible for the object to be traveling with non-zero velocity? If yes, state the condition that must be placed in the magnitude and direction of the velocity. If no, provide a reason. Yes. Okay. Anybody else? Yes, please. Yes. So the both situation can be there. Otherwise, the body can be at rest also initially, or it can be in the state of motion also. Okay, na? If it is in the state of motion, then motion, comma, no net external according to Newton's first law of motion, comma, no net external force is required to move an object with constant velocity. To move an object with constant velocity. Full stop. So, comma, an object travels. So, an object travels with a constant velocity. An object travels with a constant velocity when it experiences a net zero. When it experiences a net zero external unbalanced force. External unbalanced force. Full stop. An external unbalanced force. Full stop. An object may also not move at all if it experience no external unbalanced force. No external unbalanced force. Full stop. This is because the object may be at rest. The object may be at rest in the beginning. The object may be at rest in the beginning. I hope the situation is clear to everyone. Okay, let's move on to the next question. What is next question? Question number 4. Question number 4, very easy question. Simple. A batsman hits a cricket ball when rolls on a level ground. After covering a short distance, the ball comes to rest. So when a ball comes to rest, the ball slows to stop because of very good. And that force is known as force of friction. Okay, please tick this C part. No need to write down the MCQ on the notebook. Just tick it and just mention the option name. Okay, mention the option name. Okay, next one. Next question is fifth one. Fifth you have done. Sixth question. A stone of 1 kg is thrown with a velocity of 20 meters per second across a frozen surface of lake and comes to rest after traveling a distance of 50 meters. That is very easy. What is the force of friction between stone and the ice? So what is given to you? Mass is already provided to you. Okay. Yes, mass is already given to you. Mass is already given to you, that is 1 kg, and after that U is already given to you, 20 meters per second. Okay, next is traveling with this distance is 50 meters. Okay, and comes to rest. T is equal to 0. What I need to calculate is F. F is equal to M into A. Okay, so what is the value for this A? B minus U upon T. T is not given to you. Okay, so what will we just use this formula? Which one? V square minus U square is equal to 2AS. So we will use this formula. V square minus U square is equal to 2AS. What is V square here? It is 0 square minus U square, that is 20 square, is equal to 2AS. 2 into A into S. So it will be minus 400 is equal to 100A. What will be the value for A here? Minus 4 meter per second square. So what will be the value for this? What will be the value for force here? Force. What was the mass? 1. And what is the acceleration here? Minus 4. So the force will be minus 4 Newton. Okay, so we will continue next time. Thank you so much.